Hey guys, let's look at page 25. Let's go ahead and get this set up so that tomorrow we can hit the ground running. Lab exploring osmosis. So remember from the concept 2 notes that you have, osmosis is just simply the flow of water. And everything flows naturally from a high concentration down to a low concentration. Whoops. So from high to low. Guiding question: how will the size of the cell, represented by a gummy bear, change in different types of water? So we talked about this just a little bit on Friday. Purpose: to investigate the movement of different types of water into and out of the gummy bear. So let's make a hypothesis here. Make predictions about how each of the three types of water will affect the size of the gummy bear. So below here, you're going to make three hypotheses. One about tap water, distilled water, and then salt water. So let's go through each of these and just kind of think about what may happen, and then I'm going to let you come up with your hypothesis. So, tap water, distilled water, and salt water. So if I have a beaker of tap water, remember, tap water is not pure water. There's other things in here. So we can have chlorine, we can have um, fluorine or fluoride. We can have maybe some trace amounts of sodium. Um, Maybe there's some sulfur here also. So here, let's say that this is 90% water. Okay, so let me give me some more room here. I want to delete everything. That might be what I have to do. So once again, I got my tap water in my beaker. And let's say that my gummy bear here, inside of it is 50% water. Even though I know it's not, we looked at a gummy bear, it's not 50%. We're just using some numbers. And we said that this tap water was going to be 90% water. We said everything flows from a concentration of high to low. So outside of my gummy bear, I have a high concentration. Inside my gummy bear, I'm going to have a low concentration. So we're going to flow from high to low. So for tap water, make me a prediction about the size of the gummy bear. And how are we going to measure size? We're going to measure mass. So somewhere by size, I want you to write mass. And our format, if independent variable, then dependent variable. My independent variable is what I'm controlling. So my tap water, distilled water, salt water, all of these are going to be my independent variables. So my dependent variable is what I'm measuring, which is my mass. So make me a hypothesis. If we are placed in tap water, then what do you think is going to happen to mass? Do you think mass of our gummy bear is going to increase, or mass of our gummy bear is going to decrease based upon the premises of osmosis and water flowing from a high concentration to a low concentration? So pause here if you need to make that first hypothesis, and then we're going to talk about the second hypothesis. All right, next up, we're going to have a beaker, and in this beaker, we're going to have distilled water. Remember, we talked about this Friday. Distilled water is just pure water, 100% water. So we're going to put our gummy bear in, which is our cell, and we have 100% water here. We said, just to have a number to compare to, we would use 50% here. water flows, and this is distilled water, which is just pure water, nothing else, flows from high to low. So my second hypothesis here, we always use if independent variable, then dependent variable. So if independent variable, which is my distilled water, then dependent variable. Remember, dependent is what we measure. We said we're measuring the size, which is the mass. So what do you think is going to happen? Do you think the mass of this cell is going to increase or decrease when it's in 100% water? So pause here, make that hypothesis, and then we'll look at the third one. My third one, salt water. So after, we need to make this clear, it says after our bear has been in the tap water, it's going to be placed in the distilled water. So we're going to have the tap water bear for 24 hours, measure him, put him in the distilled water for 24 hours and measure him. And then after that, we're going to put him in the salt water after 24 hours. Okay, so my independent variable here is salt water. So here's my beaker. Here's my cell. And remember, this is going to be 24 hours after it's sitting in distilled water. So maybe now we have 70% water inside, and maybe outside we only have 50%. Water naturally flows from high to low. So we have a high concentration here flowing to a low concentration. So water is going to leave this cell. So my third hypothesis here, if independent variable, then dependent variable. My independent variable is salt water. So if a gummy bear is placed in salt water, then my dependent variable here is my size, which we said was mass. So you tell me, what do you think happens? Do you think the mass of this cell or this gummy bear, which is our cell, do you think it is going to increase or decrease? Let's go ahead and make me a hypothesis. You should have 3 hypotheses recorded. We want to be ready to rock and roll tomorrow, so that as soon as we come in, we can get this going. Please read this procedure. When you come in tomorrow, I'm just going to let you take off after your prime time and get this started. Okay? It's going to take 3 days. Go ahead and record what color of gummy bear you would like. So if you want red or green, I think there's yellow. And then record you a color here. I'll let you choose your color. You're going to get your mass in grams tomorrow when you come in. And then here, we're going to pause on this. We may use Google Sheets. I'm not sure. We'll tackle that when we get there. So please read this. Please have your hypothesis ready. And you can move on to the next video where we're going to work on our lab report.